So again, I hope you're in a better position ngayon, no? Kasi with all the things that's happening around us, no? Medyo delikado na. Okay. So let's start our discussion with chapter 3, which is more on the formation of chemical bonds. Now we'll have an overview of the chemical bonds, and this is actually divided into two. Now, the first one is in the lecture wherein I will discuss to you the reason why we have bonds and what is ionic bond and how to name them. Okay, so yun yung sa lecture component. For the laboratory, your lab prof should discuss the Lewis structure for covalent molecules. Okay, so yun lang naman na. So I hope that you have started with your lab na, no? Okay, I hope that you know how to draw Lewis structure by this time. Okay. Anyway, the content of chapter 3 in the lecture is independent naman with the laboratory. Okay? So, in this chapter, we're going to take a look into the basics of chemical bonding. And of course, together with this is you should be able to write the electron configuration already. Okay? So, electron configuration has been a topic in your, I think, laboratory na. Okay, so yun. I hope that you are able to do electron configurations na. And then you should also keep in mind the periodic trends because this will help us think faster, no, in determining whether we have an ionic molecule or a covalent molecule. Okay. So again, for this chapter, we're going just to have a review on the concepts of the formation of ions, okay, and the difference of ionic and covalent bond. And then on the later half of this session, we will proceed with the nomenclature. Again, the nomenclature is more on memorization. So I will just walk you through the process, and then I expect you to memorize all those things in the future. Okay. If you are unable to memorize them, that's fine. You can still write a código naman. Okay, so that's okay with me. That's why I uploaded on Canvas a código rin. No? Okay, so ito. So, saan nyo makikita? In the practice quiz na. So, in the practice quiz for module, for chapter 3, you will see this código. Okay, so yun lang. Okay, kasi I think some of you might remember all these things agad, no? But not all, no, are good in memorization, no? So, man, I'll give you that opportunity. Pero I hope that by the end of this session, no, by the end of this semester, you already know how to name molecules or ions, okay? So anyway, let's proceed, no? So for this part of the session, I will not use the PowerPoint, okay? Rather, I'll use a whiteboard instead, no? Because I want to make a logical flow muna, no? Okay, so allow me to use this whiteboard and then let's proceed with our discussion. Okay, so now let's talk about the formation of ions. Okay, so why do we form bonds? Okay, why do atoms combine, no? Bakit nga ba? Okay, the primary reason is that atoms want to be stable. That's why they combine. Okay, so the way they combine differs. Some of them combines through ionic bond. Some of them combines via covalent bond. But regardless of the process, no, the atoms want to be stable. That's why they do chemical bonding. Okay. When I say stable, no, ano ba point ka dun? Okay. When I say stability for atoms, no, I am referring the to the behavior of the noble gases, no. Okay? Because apparently noble gases doesn't react that much, okay? So hindi nagre-react ang ating noble gases. Okay? So that is the idea of stability in atoms, okay? So again, keep in mind that for atoms, for them to be stable, they want to imitate the noble gases, okay? So just like us, so if you want to be financially stable, You may want to imitate the behaviors of rich people, no? For example, yung mga solusyutan, no? You want to copy what that person is doing, no? That person is engaging in business, so that means you have to copy it, okay? So yun yung idea ng stability, no? Okay, especially kunwari financial stability, no? If you want to gain financial stability, then you have to be the person that you are looking for, diba? Okay, you have to work, you have to create your own business, no? You have to invest in stocks, no? Okay, so yun yung idea ng stability in person. However, for atoms, the idea of stability is to be like the noble gas, okay? What's with noble gases ba? Okay. The thing with noble gases is that if you write their electron configuration, no, the number of electrons are completely filled per orbital. Okay. So for example, you have helium. Okay. The electron configuration of helium is 1s2. Okay. And take a look that the 1s orbital is completely filled with 2 electrons. That gives helium its special stability, no? Kasi its electron configuration is complete, okay? So that's the idea. And all the other atoms want to copy the noble gases, no? Kasi they are stable, no? They have complete electrons in their electron configuration, okay? So what's going to happen, no, if the atom wants to be stable? Okay, so let's take a look into our uh, example here. So let's have sodium and then let's have fluorine. Suppose these two atoms want to be stable. How are we going to show that? That's easy lang, ganito. You need to write first the electron configuration of the two atoms in its ground state, okay? So, sulat muna natin ang electron configuration in the ground state. So, for sodium 11, that's 1s2, 2s2, 2p6, and 3s1. Okay, so you have 2 plus 2, 4 plus 6, 10 plus 1, 11. Okay, so that's the electron configuration of sodium. If I am going to convert this into the noble gas configuration, this should be written as neon 3s1. Okay, so I hope you know how that happened, diba? Okay, so ganito lang yan. If you want to convert your electron configuration into the noble gas configuration, all you have to do is to look for the periodic table, look for the atomic number of the noble gases. Okay, the atomic number of the noble gases will tell you the number of electrons needed for it to be like a noble gas. Okay, so for example, helium's atomic number is 2. That means it requires 2 electrons for it to be uh, helium. Okay, so kunwari, you have neon, which is 10. So that means neon needs 10 electrons. Argon is 18, so that means argon needs 18 electrons. Krypton is 36, so that means it needs 36 electrons, and so on. Okay, so again, the idea is that the number of electrons for the noble gases can be seen by their atomic numbers. Okay, so we can apply that with our electron configuration. So we have the first two electrons. This first two electron will correspond to helium. And then the next 10 electrons, this will correspond to neon. Okay. Okay, so again, based on the atomic number, you can tell what noble gas is being represented. Okay, so if you have 2 electrons, that's only helium. If you have 10 electrons, that's neon. Okay, so apparently, we can only make up to 10 electrons. So that means these electrons here are our core electrons, and this one here is our valence electron. Okay, the valence electron is outside the core electron. Okay, so again, when I say core electron, I'm referring to the noble gas configuration. Okay, and anything outside the noble gas configuration is the valence electron. Okay, so that's the electron configuration of sodium. How about fluorine? Okay, so we'll do the same process, no? So that's 1s2, 2s2, 2p5. Okay, so 2 plus 2, 4 plus 5, 9. Okay, So let's rewrite this thing into the noble gas configuration. Okay, so again, 2 electrons correspond to helium. Okay, are we able to write up to neon? No? Do we have enough electrons to write up to neon? Hindi na. Kasi again, neon requires 10 electrons. But in our case, we only have 9 electrons. So that means the noble gas that we can only write is the helium 1, okay? So that this 1s2 electron corresponds to helium, and everything else would be our valence electron. Okay, so ayan. So now, what's next? Okay, so again, the atoms want to be stable, okay? So for them to be stable, they want to do something with their electron, okay? Kasi again, the atoms want to copy the noble gases, no? When I say the atom wants to copy the noble gases, it doesn't mean that they have to transform into a different element, okay? That's nuclear reaction, okay? Pero if they want to do something that needs uh, imitation lang, okay? Kung gusto lang nila gayahin yung noble gases natin, all they have to do is to copy their electron configuration, okay? So the atoms will need to copy the electron configuration of the noble gases lang. Okay, so that's the idea. Okay, so let's take a look again at sodium. Okay, so since sodium wants to be stable, all it has to do is to copy the electron configuration of the noble gas. Okay, so now let's take a look again into our periodic table. So looking at periodic table, there are two noble gases that are near to sodium, di ba? We have the neon, okay? So, dalawa yung malapit na noble gas kay sodium, which is neon. And the next one is argon. Okay? So, ito yung dilemma ni sodium na. So, sodium is thinking on which noble gas should I copy? Okay? Aling noble gas yung maganda kaya kopyahin. Okay? So, sodium was thinking, if I copy sodium, all I have, sorry, if I copy neon, all I have to do is to lose 1 electron. Okay? If I want to copy argon, I have to gain 7 electrons. Saan nanggaling yung numbers? Okay? So, just look at the atomic numbers. Okay? So, if sodium wants to copy neon, all it needs to do is to remove this extra electron. This extra electron. If sodium wants to copy argon, then it needs to gain 7 more electrons, okay, so that it will have 18 electrons as well. So, which is easier to do? Is it to lose 1 electron or to gain 7 electron? Okay, so obviously, losing 1 electron is easier, di ba? Okay, that's easier for sodium than to gain 7 electrons, okay? And also keep in mind that sodium is a metal, and we know that metals have low ionization energy. Therefore, uh, it tends to lose electrons easily. Okay, so that's the idea. Okay, so sodium will lose the electrons so that it can copy the number of electrons of neon. Okay, so that means this 1 electron here needs to be removed from the sodium. So as we remove this, what will happen? The configuration of the sodium ion, okay, is now the neon configuration, okay? Kasi nawala na to eh. Okay? Sodium will release this electron, okay? So that it will have a noble gas configuration, okay? So since it released 1 electron, the charge of sodium atom here will be positive 1. Okay? The number of electrons you release corresponds to the positive charge you will have. Okay? So suppose sodium released 1 electron. So that means it will become positive 1 in charge. If it releases 2 electrons, it will become positive 2 in charge. If it releases 3 electrons, positive 3. Okay? So something like that. Okay, so that's the idea. Sodium will release the 3s1 electron because it's easier for it to be stable if it loses 1 electron than gaining 7. Okay, so yun yung idea. And since it lost 1 electron, its charge will be positive 1. Okay, and now let's take a look at fluorine. Okay, so let's look again into our periodic table. What noble gases are near to fluorine? Obviously, you have your helium and you have your neon. Okay, so fluorine will face the same dilemma as sodium. No? So, mag-iisip siya, no? Which of the noble gases here should I copy? Is it helium or is it neon? Now, what do you think is the answer? Okay. Anyone, pwede mag-chat. What do you think is the answer? Is it helium yung gagayahin or is it neon yung gagayahin? Obviously, it's neon. Okay, so again, the idea is that uh, the nearest noble gas, yun yung kokopyahin. Okay? So, the nearest noble gas is the thing that will be copied by your atom. Okay? So, in our case, that's neon. Because in order for fluorine to copy neon, all it needs to do is to gain 1 electron. If it wants to copy helium, then it needs to lose 7 electrons, which is too much. Okay? And also, keep in mind that fluorine is the most electronegative atom in the periodic table, meaning it really likes gaining electron. Okay? So it will not lose electron, rather it will really gain electron. So that's why it will copy the configuration of neon. So this is the question. Where will that electron come from? No? San manggagaling yung electron na gusto niya? Okay, so yun ay manggagaling from sodium. Because again, remember, earlier, sodium released the 3s1 electron so that it will be stable. That extra electron will then be accepted by fluorine atoms. Okay, so as the fluorine atoms accept the 3s1 electron of sodium, it will now be added to its electron configuration. Okay, so it will be added here. Okay, so isang electron lang, so plus 1. So what's 5 plus 1? 6 yan, di ba? And you know that since we have 10 electrons already, this will now correspond to the neon configuration. Okay? So yan. So that means by accepting one electron that was released by sodium, fluorine will now be also stable. Okay? Magiging stable na rin siya. However, since it accepted electron, it will have a negative charge. Okay? So keep in mind that when you lose electron, you become positive. When you gain electron, you become negative. No? The magnitude for positive or negative value depends on the number of electrons being released or accepted. Okay? So yun. So, since we have two charged particle, we have the cation, which is positive, and the anion, which is negative. No? So, since we have two charged particles here, they can now combine by Coulombic forces. Okay, Coulombic force states that positives are attracted to negative. Okay, so yun lang yung idea. Okay, so the positive charge is attracted to the negative. Hence, we have an ionic compound. Okay, compound. So this is an ionic compound. Okay, because we have two charged particles, the ions, the cation and the anion, held together by Coulombic forces. Okay? So, ganun lang. Very easy. Okay? So, that's the concept of the formation of ionic bonds. Okay? The atoms will just lose or gain electron depending on the requirement. Okay? Okay. When I say requirement, I'm referring to the number of um, electrons needed for it to copy the noble gas configuration. Okay, so yan. So yan, atoms will lose some electron while others gain a certain amount of electron. No? So as they do it, no, they copy the electron configuration of the noble gas, and then yan, as they all have the electron configuration of the noble gas, then they are deemed stable. Okay? So yan, stable na sila. Ganun lang, ka-easy. Let's take a look into another example here. Ano kaya? Let's have calcium. Let's have calcium and oxygen. So again, I will write the electron configuration of these two elements. Okay. So for calcium, that's 1s2, 2s2, 2p6. So 10 na yan. 3s2. Ilan na yan? 12. 3p6. 10. 18. Okay. And then 4s2. Okay. So 20. So this is the electron configuration of calcium. Now let's write the shortcut. Okay, let's write the noble gas notation. Okay, so again, all you have to do is to look into your periodic table and determine the atomic number of your noble gases. The atomic number of your noble gas will tell you the number of electrons needed to imitate these atoms here. Okay, so for example, the atomic number of helium is 2. That means the 2 electrons here correspond to helium. The atomic number of neon gives us an idea that these 10 electrons here correspond to neon. Okay, and since we have so many electrons pa, we will proceed with the next noble gas, which is argon. So argon corresponds to 18 electrons here. Okay, so 2 plus 2 plus 6 plus 2 plus 6, that's 18. Okay, so that means all these things here, okay, they all correspond to argon. Okay, and this thing here, since it's not included in the core electron, it's called the valence electron. Okay, so calcium has 2 valence electrons and its core electron correspond to argon. Now let's write the same for oxygen. So that's 1s2, 2s2, 2p4. Okay. The only noble gas we can write for oxygen is the helium. Okay. Because we don't have 10 electrons to copy the neon. Okay. So our core electron is just the helium, and then this 6 electrons out here uh, will be our valence electrons. Okay, so this is 6. Okay, so ganun lang. Now, calcium and oxygen will face the same dilemma as sodium and fluorine. Okay, they want to be stable, so that means they have to imitate the noble gases. So let's take a look at calcium. The nearest noble gas for calcium is argon and krypton. Okay, so krypton. Okay, so which of the two atoms here is nearest? Okay, so saan yung mas near kay calcium? Obviously, it's argon. Because in order for calcium to copy argon, it will just need to release 2 electrons. Okay, so from 20, you just release 2, you will have 18 na. Kasi if that's krypton, you have to gain 16 electron, which is a lot. Okay, so 16 is sobrang dami. So it will not copy the electron configuration of krypton. Okay, so that's why calcium will lose 2 electrons. Ito yan. It will lose 2 electrons so that it will have a configuration that corresponds to argon. Okay, again, since it lost 2 electrons, its charge will be positive 2. Okay, and now let's take a look into oxygen. Oxygen needs to be stable as well. Okay, so the nearest noble gases for oxygen is helium and neon. So just like calcium, okay, oxygen will face the same dilemma which of the following noble gases is nearest to oxygen? Obviously, that's neon. Okay, so that means oxygen will need to accept two electrons. Okay, so where will that two electron come from? Okay, that those two electrons will come from the calcium. Okay, because again, keep in mind that calcium released electrons for it to be stable. Those released electrons will then be accepted by oxygen. Okay, tatanggapin na niya yan. Okay, so let's add two electrons here and take a look. No? So if you count the total number of electrons here, you have 10. Okay, and 10 electrons correspond to neon. Okay, so that means oxygen is now stable, just like calcium, but it has a negative 2 charge. Okay, okay, bakit negative 2 charge? Negative 2 because it gained 2 electrons. Okay, and again, just like sodium and fluorine, they will combine by virtue of Coulombic forces. Okay, Coulombic force will tell us that positive particles are attracted to negative particles. Okay, so that's why calcium 2 plus and oxygen negative 2 will combine to form the formula CaO. Okay, calcium oxide. Okay, so they will combine to form the ionic compound, which has a formula uh, of CaO. Okay, paano nakukuha yung formula na? You might be asking. So, I know you already know this. Okay, uh, in order for us to determine the formula, we do the crisscrossing. The crisscrossing. Okay, the crisscrossing of charge happens like this. Na? So, the number here for the cation will be written down there as the subscript for the anion. And the charge for the anion will be written as the subscript of the cation. So as you can see, it should be Ca2O2. However, if your subscripts are reducible, okay, ibig sabihin kung parehas 2 yan, you can reduce that to 1 now. Okay, so these subscripts are reducible to lowest terms, which is 1. Okay, so that's why we only write CaO. Okay, but always keep in mind that the charge of calcium and oxygen is not 1. Okay, this is the common problem that students face kasi. Okay, especially my senior high school students, no. Okay, medyo may iba pa rin nalilito that time eh. Okay. So, since 1 daw kasi yung subscript, inisip nila, so that means oxygen is negative 1, calcium is positive 1. Okay, that's wrong, okay? Because we know earlier that calcium is positive 2 in charge because it loses 2 electrons, di ba? So that also means that oxygen should be negative 2 as well, okay? So hindi 1 agad yan, ha? The reason why the subscripts here are 1 is that, we just reduce the original formula to the lowest terms, okay? When you reduce a formula into the lowest term, we call that the empirical formula, okay? So you always need to reduce the formula of ionic compound to lowest terms, okay? So ayun lang. Ayun. So now, as you can see, if we try to explain everything in terms of the uh, in terms of their electron configuration, it will take a lot of time, no? To just explain the bonding between two atoms. No? Okay, so that's why in 1914, one American chemist made this thing, okay, the Lewis symbols. Okay, so in 1914, Gilbert Lewis created the Lewis dot symbol, which you use in your laboratory class to write down the structures of different molecules. Okay, so we use the Lewis dot symbols. Okay, so according to Gilbert Lewis, each element of the representative group. When I say representative, I am referring to this block here, the S block elements and the P block elements. We are going to exclude the transition metals, okay? So again, when I say representative elements, just remove the transition metals lang, okay? So according to Gilbert Lewis, those representative elements have certain number of valence electrons that correspond to their um, group number. Okay, so let me just draw a periodic table here. Oopsie. Okay, wait lang. Sulat ko lang to. Okay, so again, the idea of Gilbert Lewis is that for representative elements, their group number gives you an idea on how many valence electron they possess. Okay, so for example, you have the group 1 here. Okay, so obviously since you have a group 1 element, that means you have one valence electron. Okay, keep in mind that this is our example earlier, sodium. Sodium has one valence electron. Okay, so yan yung idea ni Gilbert Lewis. We represent the valence electron as dots. Okay, so the number of dots tells us the number of valence electron. So for group 1, the Lewis dot symbol is this one. Okay, you have your element symbol here. Okay, you replace it with HLINA, and then you represent the dot as your valence electron. Okay, so we only have one valence electron here now. For group 2, we have two valence electrons. Okay, just for example, calcium. Okay, so as you can see, we have the 4s2 electron here. So that means this group will have two valence electrons. Okay, we represent it this way. Okay, so one on the left, one on the right. Pwede rin naman nasa taas, nasa gilid. Up to you as long as they are not paired. Okay, so we can proceed up to the last column. No? So this will have three valence electrons. Okay, we represent it this way. This one has four valence electrons. Okay, so we represent it that way. Keep in mind that the valence electron should be unpaired first. Okay, so kailangan hindi siya paired. This group will have 5 valence electrons. Okay, so isa, dalawa, tatlo, apat. Then the last one should be paired. Okay, so pwede mo ilagay dito, doon. It's up to you, but I want to place it here on top. Okay, and this one will have 6 valence electron, just like for example, what we have earlier. Okay, oxygen. So it has 6 valence electrons here. 2 plus 4 is 6, right? Okay, so that means we represent oxygen with 6 dots. Okay, so you write the first 4, 1, 2, 3, 4, and then the other 2 will be paired. No, ayan. And then for fluorine, we have 7 valence electrons that will be represented by 7 dots. Okay, ayan. We have an example for that. This one, okay, so it has 7 valence electrons earlier. So 2 plus 5 is 7, right? And then lastly, for the noble gas, we have 8 valence electron except for helium. Okay? So neon, argon, krypton, they will all have 8 valence electrons. Okay? Why is that helium doesn't contain 8 electrons? The answer there is that the first energy level of the helium atom can only contain 2 electrons. Up to 2 electrons lang kasi. That's why. Okay, so only when you have second energy level, you can accept up to 8 electrons. Okay, so that's the idea. Okay, so ganun lang. Starting from second energy level, or second row, okay, you can start having 8 electrons. Okay, so again, the exclusion for this one will be helium. Okay, so helium is exempted to the rule. Okay, and even hydrogen, no, is also exempted to the rule. Okay, so yun. So let's try representing the formation of ions using the Lewis dot symbols. Okay, so let's try to redo what we did earlier. Okay, using these dots. Okay, using these symbols. Okay, let me zoom it out muna. Ayan. Ayan, ganyan na lang. Okay, so ayan. So let's try sodium again and fluorine. Okay, so let us represent sodium and fluorine as the Lewis dot symbol. So sodium is in group 1, so that means it will be represented using a single dot. Okay, and then fluorine is in group 7, so that means it needs to be represented with 7 dots. Okay, ayan. So you have 1 dot sodium, that's the valence electron of sodium. For fluorine, that's 7. Okay, so again, let's take a look into the process that they did. No, so earlier sodium released the electron, this 1 valence electron, to fluorine. So how will we represent it? We represent it this way. Okay, so we show that this electron is transferred to fluorine. Okay, so as that happens, sodium will no longer have any electron around it, and it will have a positive charge. For fluorine, it will have the complete 8 electrons, and it will have a negative charge. Okay, so this is the Lewis representation for these two atoms here. Okay, for them to be stable, sodium released 1 electron to the fluorine. This is yon, ito yon. And then as they do so, sodium will become positive in charge, and negative in charge for fluorine. Okay, for metals, for metals, you can show their stability when they don't have any electrons around them. Okay, so if you have a metal atom, keep in mind that they should have no any electrons around them as they become stable. Bakit na? Because again, keep in mind that in chapter 2, we knew that metals have low ionization energy, low electron affinity. So that's why metals will really give all the number of electrons they have. Okay? Ipapamigay nila lahat. Okay? So yun. So that's why by the end of your Lewis dot symbols, you should show that the metal doesn't have any electrons around it. While for nonmetals, you should show that they have 8 electrons. Okay? 8 electrons corresponds that to 8 electrons correspond to the nearest noble gas that they will copy. Okay? So for nonmetals, the nearest noble gas will be neon. So the neon, as you know it, it has 8 valence electrons. Okay? For nonmetals, 8 electrons are needed. That's why it's called the octet rule. Okay? Octet rule meaning walong electrons. Okay? You have 8 electrons for it to be stable. Again, that only applies to nonmetals. Okay? Such as fluorine. Okay? So, ganun lang. Let's try it again with calcium and oxygen. Okay? Calcium and oxygen. Calcium is in group 2, so I will write 2 dots. Again, the placement of that, it doesn't matter naman as long as they are not paired. Okay? So you can place your next dot here or there, it's up to you, but I want it here. Okay. Then for oxygen, again, the placement of dot doesn't really matter as long as the first four are unpaired. And then if you have excess electrons, you just pair it next. Okay. And so oxygen has 6 valence electrons. Again, the way you position your electrons doesn't really matter for now. Okay. As long as your pairing is correct. Okay, so again, just like I said earlier, if you have a metal, you have to release all the electrons to the non-metal. Okay, so lucky for us, those 2 electrons released by calcium will be all accepted by oxygen. Okay, so yan. So as we do that, we remove these 2 and we end up with this symbol. Calcium without 2 electrons with a positive charge. Oxygen with all 8 electrons but with -2 charge. Okay, so that is their Lewis dot symbol. Okay, and then just like earlier, they will combine by Coulombic forces. And look, we only needed 1 calcium atom and 1 oxygen atom to form the ionic compound. That's why the empirical formula holds true. No? 1 calcium atom is needed for 1 oxygen atom. Okay, so ganun lang. Okay, so that's basically it. Okay. So another thing, okay, so this will be discussed in your laboratory. Okay. Ito na yon, yung mga nagsasabi ko kanina, ayan na yun. Okay. Another thing is to take a look into your electronegativity. No? So again, in this practice quiz, I posted here 2 PDF files. You may want to download them and print them. Okay. So one of which is the electronegativity. Okay. So let's take a look into electronegativity. Okay. Apparently, I cannot write. Hindi ako pwede mag-drawing pala sa screen unlike Zoom. Okay. So anyway, so this is the periodic table with electronegativities written at the bottom right of the cell. Okay. So teka lang. Download na natin para mag full screen. Ayan. Ayan. So remember, we have sodium kanina, and then we have fluorine. Let's take a look into their electronegativity. Sodium is 0.9 in terms of electronegativity, and fluorine is 4.0. If you get their electronegativity difference, that's delta En, okay, that is the difference of the electronegativities of 2 atoms. For fluorine, that's 4, and for sodium, that's 0.9. Always big number minus small number, okay? So what's this? No? So 4.0 minus 0.9. This is 3.1. You have a big electronegativity difference. The idea here is that if you have a big electronegativity difference, that means the electron will be fully transferred. Okay? So what's the threshold? No? Okay. So we have a threshold actually. No? If your electronegativity difference fall greater than 1.8, then that means you have ionic bond. Okay. If your electronegativity difference is greater than 1.8, that means you have an ionic compound. Okay. So for example, sodium and fluorine, the electronegativity difference is 3.1. So meaning we have an ionic compound. Okay. However, if it falls below it, okay, you can have 2 options. You can have a polar covalent bond and a non-polar covalent. Okay, so again, the details about covalent bond will be given to you in your laboratory. Okay, however, our focus just right now is the ionic. So keep in mind that the electronegativity difference of our ionic compounds are usually greater than 1.8. Okay, they are usually greater than 1.8. So again, let's take a look into our next example earlier. You have calcium and oxygen, right? Okay, so let's determine the electronegativity difference and show that it is indeed ionic. So for calcium, that's 1.0. For oxygen, that's okay. So that's 3.5. So let's get the delta En. So big number minus small number. Okay, so this is 2.5. Okay, so the electronegativity of calcium and oxygen is indeed greater than 1.8. That indicates that there is a full transfer of electron as long as the electronegativity difference is greater than 1.8. Okay, so again, the copy of this periodic table is uploaded here in your practice test, and again, I highly suggest that you take this. Okay, the correct answers will show at the end of your attempt. Okay, at your last attempt. Okay, so that's the idea. Okay, sana gets natin ha. Okay, so let's go back to the PowerPoint. Okay, so the difference between ionic and covalent are the following. Okay, so in ionic bond, there's a complete transfer of electrons, while in the covalent bond, we only have the sharing of electrons. Again, more details about the covalent bond will be discussed in your laboratory. Okay, so also keep in mind that for ionic bond, there should be a metal and a non-metal there. Okay, so that is in most cases. And then the typical electronegativity is greater than 1.9. So actually that should be greater than 1.8. Okay, so it should be just greater than 1.8. Okay, for covalent bond, the electronegativity difference is less than 1.8. Okay, and then depending on the magnitude of your electronegativity difference, you can either have a polar covalent bond or non-polar covalent bond. Okay, so yan. And then again, just as what we shown earlier, okay, the electrons will be transferred to the non-metals. Okay, yan. So basically, we're done with the concept of formation of ions. Now, since tapos na tayo with the formation of ions, and we already discussed the determination of their ionic formulas now. Okay, so again, when you want to determine the ionic formulas, all you have to do is to do the crisscross. No? All you have to do is to do the crisscross method. Okay, so for example, you have your cation here, and then you have your anion here. All you have to do is to bring this charge down there, bring this charge down there. Okay, so your general formula would be like this now. Okay, if you can reduce this to lowest term, then that's better. Okay, so yun lang. So since we already have an idea on how ionic bonds are formed now, let us now proceed with the way we name them. Okay, so again, so this for this part, this is just purely memorization. So I will just read all the things that are written here. However, I will give you some more insights, okay, for you to easily remember them. Okay, but again, most of this part will be just memorization. Okay, so I highly suggest by the end of this session, you download the PowerPoint, you write your código, and again, I uploaded a file naman here which contains the list of common ions together with their names. Okay, that will help you memorize all these things further. Okay, but for now, let's go with the nomenclature. Okay, so in naming ionic compound, usually we name the cation first, followed by the anion. Okay, so we name the cation first plus the name of the anion. Okay, so cation followed by anion. Okay, however, in naming these two ions, there are plenty of rules to remember. Okay, so let's begin with the rules for the cation. Okay, so for cations, there are several rules. Madadali lang naman, don't worry. Okay, so the first one is that the name of the metal atom that became, sorry, mali ang aking word. The name of the metal ion from your metals, no, are usually named by the name of the metal itself. Okay, so ibig sabihin nun, if you have a metal that suddenly turned into an ion, its name will be just the name of the metal itself. Okay, so for example, you have sodium. If that loses electron, the name of this ion is still sodium. Okay, sodium pa rin siya. However, you can include the word ion to indicate that it has a positive charge. For example, earlier we have calcium. If our calcium loses electrons, it becomes calcium 2 plus. What's the name of this ion? So the name of this ion is calcium ion. Okay, so very easy. The name of the metal is usually the name of the metal ion then. Okay. However, um, if you take a look into your transition metals, no, usually transition metal have multiple charges. Why do they do that? No? Because they are stubborn. Ganito ang dahilan. The reason why they do that is that um, these metals here, no, the metals here, they don't follow the rules. Okay? Kasi they don't follow the rules when they give off or lose electrons because they have d orbitals na. The thing with transition metals is that they have d orbitals. If atoms if your atom contains d orbital, they will violate all the existing rules that you have. Okay, so yun yung idea. Even in your Lewis structure, no, so there are several violations to the octet rule. One of them is the expanded octet. Okay, when we say expanded octet, that means you have more than 8 electrons in your central atom, right? Okay, so I hope that you have an idea about that already. Okay, so yun. So the thing with transition metals is that they do not follow the rules. So that means their charges vary. Okay, they have multiple charges. However, for our representative elements here and here, they follow the rules well. Okay, so that's why depending on their group number, you have your charge. Okay, however, again, for transition metals, they really don't follow the rules that much. Okay, mga pasaway sila. Okay, so ayun. So since you have multiple charges for transition metal, then you should indicate the charge, no? Because the behavior of two different ions will be very chemically different. Okay, for example, the behavior of Fe2 plus will be different with the behavior of Fe3 plus. Okay, so it will have different chemical reactivities. Okay, so yun yung idea, no? If we just name the two ion, then we can no longer distinguish which type of ion are you pertaining. Okay, so are you pertaining to the 2 plus or the 3 plus? Okay, so to eliminate that yung ambiguity or ambiguous. So to eliminate the ambiguity, we have to indicate the charges with Roman numerals in parentheses. Okay, because again, transition metals don't follow the rules. Okay, they usually form multiple charges. So in order for us to differentiate what charge of your ion you're pertaining to, you have to indicate the charge with your Roman numeral enclosed in a parenthesis. So for example, you have iron 2 plus, you name it as iron 2 ion. Iron meaning iron metal. This charge 2 here refers to the positive 2 charge there. Okay? So, ganun lang. So, that is to eliminate the confusion. Yung confusion of the highest order. Okay? Baka kasi mo-confuse kay lalo. No? So, that's why we have to indicate the charge. Okay? So, for copper, we have copper 1, copper 2. So, this was copper 1. This is copper 2. So as you can see, they have different charges. So that means they should have different name as well. Another example will be lead. So there are two types of lead. Okay, the Pb2 plus and the Pb4 plus. So you name this as lead 2 and then you name this as lead 4. Okay, so make sure you know how to write you know how to write Roman numerals. We're doing it since kinder. Ako kinder eh. 1, 2, 3. Ayan. 4, 5, 6. Okay? So up to 6 lang naman usually. Okay? So we indicate the charges with those Roman numerals. However, let's proceed with the next one. However, in the olden times, they don't use this. Hindi nila ginagamit to in the olden times. It's probably around 15th or 16th century. No? Instead, they use their old method. Okay? They use their old method. Ano yung ginagawa in the old method? You show the Latin name of your element and you use the suffix us and ik to differentiate the two charges. Okay? So this old method will only apply if you have two charges. Okay? Two charges only. Okay, so for example, Fe2 plus, Fe3 plus, copper 2 plus, Pb2 plus, Pb4 plus. Okay, so as long as your transition metals only contain two charges, okay, they can only form two charges, then um, you can name them using their older method. No? How do we name using this method? Ganito lang, you just get the root word of your Latin name. Okay, so basically you just remove the ito yung question. Mary asked, sir, paano pag naging 3 yung charge? This is the problem that old chemists faced. Okay, kasi by their time, dalawa lang yung charge na na-discover nila. However, as science progressed, na observe nila that there are multiple charges. So that's why they abandoned this thing and then they stuck with they followed this rule na lang. Okay? So that means if you have multiple charges, most probably um, you will use this rule here. Okay? Pero if you have only two charges, you may use the old method. Okay? Kasi in older times ng chemistry, no, alam nila dalawa lang yung charge eh. Pero over time, nakadiscover sila, ay, ang dami pa palang ion. So, let's abandon this thing. Let's use this new method. Okay? So, yan. So, that means if you have multiple charges, 3 or 4 charges, you need to use this thing here. Okay? So, yan. Okay, so again, how to use this method? Ganito lang. You just get their Latin name, okay? You just get their Latin name and remove the okay? For example, iron, ferrum. You just remove the okay? Okay? That's the root word for the iron, fer, okay? And then for copper, the original name is cuprum, you just remove the So that's why its root word is copper. Copper. Okay? So doon nanggaling yung copper. Okay? Copper. Okay? For lead, that's plumbum. Plumbum. Doesn't matter as long as the spelling is correct. So plumbum. Okay? So you just remove the Okay? And the root word is plumb. Okay? So yan. Then, you're going to affix two suffixes. Okay? You have the us and the ik. Okay? The us will be used for the lower charges. Okay? And the ik will be used for higher charges. Okay? For example, between 2 plus and 3 plus of iron, which is the lowest? Obviously, it's the 2. That's why if you have a lowest charge, you have to use the suffix us. If that's the highest charge among the two, you have to use the ik. Okay? So same thing as with this one. If you have copper positive 1 compared to copper positive 2, okay, you use the us here and then you use the ik here. Okay? So ganun lang. How about this one? Lead. Okay, so again, the root word here is plumb. This is also plumb. Okay, so this is 2, this is 4. Okay, so which of them will need will use the suffix us? Okay, so obviously it's the 2 plus because 2 is lower than 4. Okay, so this will be plumbus, and this one will be plumbic. Okay, so the idea here is that between two charges, if your charge is lower, then you use the suffix us, and if your charge is higher, then you use the suffix ik. However, again, this method was faced with an issue, especially when we discovered more metals. Okay, by the time chemists discovered more elements, more metals, more charges, that means there are certain elements that do not follow this rule anymore. Okay, so what we do is that we use this method here. Okay, and this is the more correct method. Okay, however, we still have to remember that we see these names in medicines, no? Especially in pharmacy, they use this method. Okay, so if you are anemic, probably you might have um, taken ferrous sulfate. Okay, and so ferrous sulfate, the ferrous there refers to Fe2 plus. Okay, it refers to Fe2 plus. Okay, so this method is used mostly in pharmacy. Okay, so if you have pharma friends from other university, and they are very familiar with this method. Okay, kasi that's how medicines got their name. Okay, so they use the old name. Okay, so yun, so ferrous sulfate na. So that's one of the best example of the use of the old method in the modern times. Okay. However, I saw some bottles now that use iron 2 sulfate instead of ferrous sulfate. Uh, this method kasi, wherein you write your charge with Roman numerals, this is better. Okay? And this is indeed better because you can see the charge itself. Pag ganito kasi, if us-ik yan, you cannot you cannot determine the charge, no, unless you memorized it, no. Okay, nangyari to sa akin nung high school. I was third year high school, no, way back 2013. 2013, third year high school ako. I was really struggling remembering the charges, no? Kasi alam ko lang low charge, ik high charge. Then the question is, what is the charge of ferrous? Sabi ko, ano ba siya? Basta alam ko low charge eh. Pero di ko alam kung positive 1, 2, 3. Anyway, so that's the idea, no? If you really don't memorize the charge, no, you cannot distinguish which one is the which one is the ik. Okay, so that's why chemists find this method really really outdated. Okay, so that's why we opted to use this newer method here below. Okay, so this is what we use in the modern times. Okay, pero dati we use this. Okay, still we have to keep in mind that the rules for this one, okay, because most of the medicines right now are still named using this method. Okay, so yan, so that's the third rule for the cation. And then lastly, we have cations formed from nonmetals, and actually there dalawa lang naman sila. We have the H plus and the NH4. Okay, H plus is named as hydronium, and NH4 is named as ammonium. Okay, take a look that their suffix are the same. They all end with "-ium." Okay, so as long as you see an ion that has an "-ium" suffix in it, that means it is a cation. Okay, dalawa lang naman sila, so all you have to do is to remember them talaga. Okay, you just remember the hydronium and the ammonium. So those are the only two non-metal cations. Okay? However, for metals, yan yung rules. Okay? So, ayan. Ayan. Naantok pa ako. I'm kinda sleepy. Sir, sa positive lang po ay, sa ngayon, positive lang. Okay? Because we are still in the cation. Later on, we will proceed with the anion. Okay? So for now, we are doing all the cations first, no? Because we name the cations muna eh. Okay. So these are the names of your cations. Okay. So yan. So now, let's proceed with the negatively charged particles, the anions. Okay? So for anions, there will be different rules than the cations. Ang dami pa. Kaya sabi ko sa inyo, memorize nyo na lang to. No? And don't worry, ako naman, when I first encountered this, no, I really find it hard nung una. Pero over time, you will just memorize it na lang. Okay? For me, it took me 8 years, no, para ma-memorize yung completely. Starting nung third year high school ako. Doon ako nagkaroon ng first chemistry until college, until now. Okay, so that's fine. No? If you cannot memorize all these things, no, that's okay with me. However, please try. Please try to memorize them. Okay? Because you need this kasi you need this knowledge. Okay? Later on, I will show you one of the blunders in USA that will show you the need to memorize this thing. Okay? After the class, pakita ko yung issue sa USA. Okay? So anyway, so we are just naming cations. Now let's proceed with the anions. And the rules for anions, no, very different siya with the cation. Okay? So there are two types of an ion. We have the non-oxy non-oxy anions, and then we have the oxy anion. Okay? So there are two types of an ion, the non-oxy anion and the oxy anion. Okay? So yun lang. Later on, you will see what is an oxy anion. Okay? So later na lang. Okay. So now we are actually pertaining to the non-oxy anion. Sorry. The non-oxy anions muna. Okay. Kumain kasi ako mangga. Kaya nadigay. Anyway. So, if you have a non-oxy anion, especially monoatomic anion, they usually end with the suffix ide. Okay, ide. Ide. Okay, parang Japanese siya. Ide. Ide. So, yan. Monoatomic anions usually end with the suffix ide or ide. Okay, so examples are the following: hydride, oxide, nitride, okay, phosphide. Okay, so all of those ends with the suffix ide. However, there are some um, binary anions that also contain the suffix ide, na, such as the cyanides and the hydroxides. Okay, so ayun. So again, if they are monoatomic, they end with ide. However, there are some diatomic that ends with ide pa rin, okay? Such as the cyanide and the hydroxide, okay? So, yan, remember na lang, okay? So, monoatomic, ide. However, there are some, such as hydroxide and cyanide, that are diatomic, okay? So, keep in mind that we are now talking about an ion, so their charges must be negative. Yan, naantok pa ako. Next one, I have the oxyanion. So, this is now the second type of anion, the oxyanion. Okay, so what is an oxyanion? This refers to a polyatomic ion that contains oxygen, okay? Multiple oxygens, okay? So, for example, we have your carbonate. Okay, so as you can see, you have 3 oxygens attached to the carbon, okay? So as long as you see multiple oxygens attached to your atom, that is an oxyanion. An ion with oxygen, okay? So yan. So that's oxyanion, and that is different with non-oxyanions, okay? So yun ha, just remember that. Okay, so in naming our oxyanions, there are several rules now that you have to remember. If that is a common oxyanion, it usually ends with the suffix ate. Okay, 8. If that is one less oxygen than common, it will end with the suffix ite, ite. Okay, so again, common oxyanions end with the suffix 8. One oxygen less than the common oxyanion, they usually end with the suffix ite. Okay, so for example, this is the common oxyanion. Okay, you have to remember this. Okay, so kasi ganun talaga siya. You have to remember all the common oxyanion, and you will know that that is a common oxyanion if it ends with the suffix ate. Okay, so this is ate. Okay, so yan. So these are the common oxyanions. They all end with the suffix ate. Okay, so for nitrate, that is NO3. For sulfate, that's SO4. For chlorate, that's ClO4. For phosphate, it's PO4 negative 3. Okay? So, you just have to remember all these things, ha? Kabisado-kabisado lang yan. Okay? So, again, that's why I uploaded in Canvas this list here. Okay? Asa na yung mouse ko? Ito. So, that's why I uploaded here sa Canvas the list of the anions that you have to remember. Okay? So, as long as they end with the suffix ate, that means they are common oxyanion. So, carbonate, nitrate, phosphate, sulfate, chromate, chlorate, acetate, all those things. If they end with 8, that means they are the common oxyanion, and you have to remember them na lang. Okay? Anyway, let's go back. Ayan. So, yan. If you remove one oxygen from these oxyanions, if you remove one oxygen from these oxyanions, what will happen? You will change the suffix to ite, the ite. Okay? So for example, in NO3, you have 3 oxygens. If I remove one oxygen here, it will become NO2. The name of this NO2 will be nitrite. Okay? So again, keep in mind that if I remove one oxygen, the suffix will end with ite. Okay? Ite. Nitrate, nitrite. What's the difference? Nitrite is 1 oxygen less than the common. This is 2, that one is 3. Okay? So, ganun yung idea. So, for sulfate, this is ate, this is the common. If I remove 1 oxygen here, so we have 4, but if I make this 3, the ate will be changed to ite. Okay? So, from sulfate, you will now have sulfite. Okay? Same thing with phosphate. Okay? So, for phosphate, if I make this oxygens 3, PO3 minus 3. So, instead of 4, I will have 3. Okay? What will be the name? It is phosphite. Okay? So, from ate, it will be etena. Okay? Just keep in mind that every time you remove one oxygen from your common oxyanion, the suffix will change from ate to ite. Okay? So, yun lang. You really have to remember all those things. That's why, again, I uploaded a file on Canvas that you may use to memorize all those things. Okay? And so, kabisado-kabisado lang talaga. Next one. There are some oxyanion that can be extended. Okay? That can be extended to 4 members. And don't worry, onti lang sila. Okay? One example of which is the chlorate system. Okay. Chlorates can be extended to 2 other oxyanions, di ba? So originally, you have your chlorite and your chlorate. Okay? Let me use my whiteboard. Okay, para mas malinis. Okay. So for chlorate, the chlorate system can be extended to 4 versions. 4 na versions meron dito. Okay? So if I remove one oxygen here, what will be the name? The ate will be changed to ite. Okay? So ganun ha. Keep in mind that if I remove one oxygen, the ate will be converted now to ite. Okay? However, I can further extend this. Okay? Pwede ko pa siya i-extend. If I add one oxygen, the formula will be ClO4 minus. What will be the name if I add one oxygen to the common? Okay, so again, this is the common. Okay, so what will be the name if I add one oxygen to the common? So according to the rules, sabi dito, you will need to affix the prefix per. Okay, per. Parang yun nasa Twitter lang lately, pati sa TikTok. Here are per. So yan. So if you add one more oxygen, you will need to use the prefix per. Okay. Here are per. Tawan-tawa ako dun kagabi. Tituloy ako nakatulog kaya inaantok ako. So yan, if you add one oxygen to your common, you will need to use the prefix per. Per, hindi P-U-R-R. P-E-R lang. Okay, so you just add the prefix per and you copy the name of your common. Yan, perchlorate. Ayan. Ayan na, may sinabi si Louie. Okay, per. Okay, so this is the oxygen ion that has the most number of oxygens. Okay, so yan. Let's remove one oxygen from your chloride. Let's remove another oxygen. -1 oxygen. If I remove one oxygen again, so what's the rule according to this PowerPoint? If you remove another oxygen, you will need to use the hypo, okay, prefix. The hypo means that you remove one oxygen from your oxyanion that ends with the ite. Okay, so for example, this is the ite. Okay, if I remove one oxygen na naman, so the formula will now be ClO. So what will be the name? You just affix the prefix hyper. Sorry, hypo pala, sorry. Hypo. Parang hypoallergenic. Yan. So, yan. Hypo, if you remove another oxygen from your ite. Per, if you add another oxygen to your common. Okay? So, Mary asked, 2 oxygens po pag nababawas. Yes, 2 oxygens. So, from your chlorate, if you remove 2 oxygens, it will be hypo. Okay? Ayan. So, yan. Kasi 1 oxygen will give you ite. If you remove 2 oxygens, it will give you the hypo ite. Okay? So, yun yung ganap. Okay? So, yan. That is if yung iyong basis ay common. If you remove 2 oxygens, then you will indeed come up with the hypo name. Okay? So, ganun. Okay, so that's the idea. Some oxygen ions have multiple charges and onti lang sila, don't worry. Okay, so onti lang sila. Okay, so for example, this one, the chlorate system, this is the best example of this. We actually have bromate then, bromate. Okay. So we also have the bromate system. Let me give you the idea again. Okay. Okay, let's try to give the names. So this is the common. And that is the common. The BRO3. Again, you just have to memorize all the commons. Okay. So yan. So this is bromate. Okay. So now let's try to name the other 3. Okay. So this one here above, okay, the common, we just added 1 oxygen, right? Okay. So that means we have to use the per prefix now. So per bromate. Okay. You just affix the per to your bromate. Okay. Kasi 1 oxygen yung nadagdag. How about this one? What will be the name of this ion here? Okay, so as you can see, this is 1 oxygen less than your common, -1 oxygen. Okay, so I remove 1 oxygen here, so the name will be From bromate, it will be bromite. Okay? So from ate, you change it to ite. Okay? Bromate, bromite. The difference is that this one has one oxygen less than than the common. Okay? What will be the name of this one? What do you think? Ano kaya name na to? Kaya, you may chat sa chat box. What will be the name of this thing here? Okay? What's the name of the BRO minus ion? The name of the BRO minus ion is ano? Hypobromite. Yes, you're correct. Ganun lang. Okay? Hypobromite. Okay? Okay? So, ganun lang. Yeah, you're correct na. So, from ite, since you remove another oxygen, you just need to affix the hypo prefix na. Para siyang hypoallergenic. Okay? Okay? Sa pag hypo, low allergy. Ganun na lang isipin nyo. Okay? 'Di ba pag hypoallergenic, pang low allergies. Ayan. Okay. So that's the uh ano, um that's the rule for oxy and ion. Okay? So now let's proceed with the next rule. Ang daming rule. So again, you just have to memorize all these things na. You have to memorize the rules, especially the common oxy and ion. And again, all of them can be found in your canvas. Okay? So dito na lahat ng mga kailangan isabuhay. Okay? If you have periodic table that has a list of ions at the back, that's better. Okay? Now let's proceed with the last rule. Okay. So the last rule tells us that we can get an anion derived by adding H+, the hydronium ion. Okay? Okay. By adding certain amount of hydronium ion to our oxygen ion, we can still get an oxygen ion. Paano nangyayari yan? How that happens? Ganito lang. Wait lang. Yan. So, for example, we have carbonate here. If I add hydronium ion, what will happen? So basically, I will just combine the elements and the charge will be combined as well. So -2 plus 1 is -1. This one is named carbonate. Okay. This one is named hydronium. What's the name of this one? We don't know. Okay, because apparently there are no rules yet in naming this thing. Okay. So, paano natin papangalanan, no? How will we name this? Ganito daw. According to this rule here, this is the last, okay? According to this last rule here, if you add H plus and that results to an anion, okay, then you have to affix the prefix hydrogen to the name of your oxyanion, okay? So, paano yun? Uli, ganito. I added one hydrogen to the carbonate. This is the formula, so the name will be hydrogen carbonate. Okay, so that's the name now. So that's the rule according to this last one. If I add H plus to my oxyanion, the name will be hydrogen carbonate. Okay, hydrogen phosphate. Okay, something like that. Okay, so yan. So yan, if I add one H and I still get a negative charge, then that means I will name it as hydrogen carbonate. Another way of naming this now is instead of using hydrogen, you can use the prefix bicarbonate. Okay? Yan, bicarbonate. So instead of using hydrogen, you can use the prefix bi. Okay? Bicarbonate, which is present in your baking powder and baking soda, bicarbonates. Okay? Ano pa? Bisulfate, no? So for example, you have sulfate. Okay, so SO4 -2. If we add hydronium ion here, you will get HSO4. So this is -2 plus 1. This will become negative 1. So as you can see, it is still an anion. Okay, anion pa rin yan. So what will be the name of this ion? So this is bisulfate. Okay, so the name is sulfate. Since we just added one hydrogen, you have to affix the bi. Or it would be named as well as hydrogen sulfate. Okay, so both will work naman. Okay, both are acceptable. However, ako, I prefer the prefix bi. Why? 2 letters lang eh. so, so that's why I always write my H, that's why I always write this as bicarbonate, bisulfate, because one hydrogen lang naman eh. So, and then dalawang letters lang siya. So that's easier to write. Okay? So yan. Okay, so suppose I want to add another H here. Okay, so suppose I want to add another H plus here. Will this rule still hold true? Okay, tignan natin. If I add another H here, I will end up with the formula H2SO4, and the charges will be 0. Okay, so this is negative 1, this is positive 1. If you combine them, that's 0. Okay, since you don't have any charge here, that means it is not an anion. Okay, so iba yung naming dito. Okay, so this rule will not hold true for neutral molecules. Okay, so again, this rule will not hold true for neutral molecules. It will only work for anions. Okay, so yun lang. Keep that in mind. So you cannot actually add many hydrogens talaga. You are limited, no? No. So yan. Kasi if you add hydrogens, no, if you add too much hydrogens, then most likely you will not end up with an anion. No? You will end up with a neutral particle. Okay. So the technique here is that if your anion is -2 in charge, you can only add one hydrogen. You can only add one hydronium ion. That's the limit. Okay. So for carbonate, you can only have up to bicarbonate. For sulfate, you can only have up to bisulfate. Okay. So yan. So now let's take a look into the -3 charge, which is phosphate. Okay. So for phosphate, I can add one H plus to make it HPO4. Add the charges. This is -3. This is +1. -3 plus 1, -2. So it is still an oxyanion. So what will be the name of this one? It can be named hydrogen phosphate or biphosphate. Okay, since I just added one hydrogen. Is it possible for me to add another H plus? Yes, no? So let's see. If I add one H plus again, the formula will now look like this. So this is -2 plus 1, that will be -1. So as you can see, it still has a negative charge. Now may negative charge pa rin siya. So I can still use this rule here. Okay, so I can still use this second rule. Okay, because this is still an anion. So what will be the name? If I added 2 hydrogens, then the name will now be dihydrogen phosphate na. Okay, so wala na siyang biphosphate. It will now be called dihydrogen phosphate. Yun na yan. Okay, so yan. Wala na siyang biphosphate, something na dihydrogen na siya. Okay, so again, if your charge is -2, you can only add up to 1 hydrogen. However, if your charge is -3, you can add up to 2 hydrogens. Okay, can be added. Okay, something like that. So yan, kapag negative in charge, you can add up to 2 hydrogens. So that means you can have a biphosphate and a dihydrogen phosphate. However, if -2 yan, such as carbonates, sulfates, yan, up to 1 hydrogen lang. If your oxyanion has a -1 charge, then hindi ka pwede maglagay ng hydrogen. Okay? Because -1 if you add the charge of the hydronium ion, the overall charge will be 0. Okay, so -1 plus 1 is 0. So this rule will not hold true for those molecules. Okay, so, so basically that's all the rules for our cations and anions. So you just have to memorize them, no? However, as you can see, there are certain patterns, no, na you can notice. Okay. Now, let's talk about ionic compounds again. How do we name them? So basically, you name your cation based on the rules I said earlier, and you name your anion based on the rules I said earlier, and then you combine them. Okay. So for example, we have the calcium 2 plus and the Cl minus. What will be the formula? So you do the crisscross. These two will go here. This one charge will go there. So the formula will be CaCl2. So what's the name? The name of the cation is calcium, and the name of the Cl ion is chloride. Okay, so this is a monoatomic anion, so that's chloride. No? As long as it ends with ide, it means it is a monoatomic anion according to rule number 2. Okay, so yeah, so the name of this compound here is calcium chloride. No? Calcium refers to Ca2 plus, chloride refers to Cl minus. Okay, how about this one? Okay, so what are the ions from this molecule here? Okay, if you want to determine the ions, you want to do the reverse crisscross. Okay, so when you do the crisscross, you bring down the charges, diba? To make it the subscript. When I say reverse crisscross, what we do here is that the subscripts will be, um, uh, tawag dun? And they will be raised to the exponent part, okay? So instead of bringing them down, you have to raise them to be the charges, okay? So ganun gagawin natin. So what are the ions that we have here? Okay, so let me rewrite it here. So this 3, where did this thing came from? This came from the Al, okay? And the one here in aluminum, it is not shown. However, you should keep in mind that there is a 1 subscript there. So where did this came from? It came from the nitrate, okay? So ganun. Okay, so that's how you do the reverse crisscross. The subscripts are being converted back to the exponent. Okay, the metals will always have a positive charge. Okay, keep that in mind. So what's the name of this ion? This is aluminum. The name of this oxyanion is nitrate. So the name of the compound is aluminum nitrate. Okay. How about this one? The next one. Okay, so for the next one, we have this Cu. Okay, so let's do the reverse crisscross. Where this, where did this thing came from? This 2 subscript here came from the copper. Okay, so it came from copper. Since copper is a metal, it's positively charged. So the 1 subscript for the copper came from the ClO4. Okay, so that's how you reverse crisscross. You determine where did this thing came from. Okay, okay, so yun. So that thing came from copper. Okay, so what's the name of Cu2 plus? There are 2 names for Cu2 plus. We have the copper 2, and we also have the cupric. Okay, we can name it as copper 2 or cupric. And the name for this oxyanion is perchlorate. Okay, so that means we have 2 names for this compound. We can name it as copper 2 perchlorate or cupric perchlorate. Okay, so again, you have to really recall your understanding on doing the crisscross. Okay, if you can reduce them to lowest terms, that's okay. And you have to also remember how to convert your subscripts into charges. Okay, So I'll give you some more examples. Wait lang. Asan yung mouse? Ay, ito. So yan, let's have some more examples. Ito. What is the charge of the particles here? What is the charge of the ions here? Okay, so basically your subscripts will be converted to the exponent. So this 2 came from here, this one came from here. Okay, so ganun lang. So you remove this because you made this the exponent. Since this is a metal, it will have a positive charge, and this is a non-metal, so it will have a negative charge. Okay, how about if you have polyatomic ions? For example, we have copper 2 plus and then SO4 negative 2. How about this one? Okay, so for this one, if you're going to do the crisscross, I always instruct my students to write parentheses around your polyatomic ion. You always need to write parentheses outside your polyatomic ion. Why? No? Because some students commit this mistake. No? Some people do this. No? So itong 2 na to, they place it next to the oxygen, and they think, and then they think that you should multiply the 2. So ginagawa nila, that becomes SO8. Is this correct? Obviously not. No. Okay, so that is the reason why I want you to write a parenthesis around your polyatomic anion so that you will not be confused with the subscripts. Na baka kasi isipin nyo 42 oxygens. Ano yung bomba? Hindi yan bomba. Okay? So, baka isipin nyo, ang dami oxygens, 42. Hindi na kaya i-Lewis structure yan. Okay? And also, that doesn't mean that you have to multiply them. No? That's also wrong. So instead, what you have to do is to put this charge here outside the parenthesis. Okay? If that's a polyatomic ion, you have to put the charge outside the parenthesis. Okay? So the formula will be Cu2SO4 2. And again, as you can see, both of them has subscript 2. So that means you can reduce it to lowest terms. Okay, when you reduce it to lowest terms, that becomes copper sulfate. Okay, copper 2 sulfate, CuSO4. However, if you're going to do the reverse crisscross, ito, if you're going to do the reverse crisscross for this one, baka kasi isipin nyo, this came from this, no? And this one came from this, so that means the formula is Cu4 plus SO negative. Is that correct? Obviously not. Okay. So when you're doing reverse crisscross, you really have to be careful. If you have a polyatomic ion, you have to put a parenthesis around it. Okay. And whatever is the subscript outside the parenthesis, that is the thing that you should bring up there. Okay. So this one will have a subscript 1. This one will have a subscript 1. But keep in mind that sulfate always have a negative 2 charge. So that means copper here will also have a negative, will also have a positive 2 charge. Okay. What just happened is that we reduce the charges to the lowest term possible. Okay. So again, these are just some reminders. Most of you have encountered this probably in your high school, junior high, senior high, especially sa physical science. Before, I also taught students about physical science, and so this is one of our topics. Okay, so dito sila nahihirapan din, but again, it will really take some time for you to memorize all these things. How about this one? What will be the formula? Okay, so let's do the crisscross. As you can see, we have polyatomic ions. When you say polyatomic ions, ion with many atoms. Okay, so this has many atoms. Obviously, it has 5. This one has 4. So you have to write parentheses around it. And then only at the time you write the parentheses, you can bring down the charges na. Okay, so this 3 will be placed here, the 1 will be placed there. So the formula will become NH4, close parenthesis 3, PO3. What is the name of this compound? So the name of this ion here is ammonium. The name of this ion here is phosphide. Okay, so again, this is one oxygen less than the common. Okay, so again, you really have to remember everything, all the rules I stated earlier. To make that easier, you can just print out the PDF file I uploaded in Canvas, and you can try to answer the practice quiz. Okay, because let's take a preview again. So the practice quiz looks like this. You have your ions here. You have to name them accordingly. These are your cations, and then you do the crisscross. So you will get the formula, and below here you can type your names. Okay, you should follow uh, the method that is indicated here. Okay, ayun. Okay, so yan, practice na lang kayo dyan. What else? Ayan. So basically, that's the rule for ionic compounds. To get the formula, you have to do the reverse, you have to do the crisscross. If you have a polyatomic ion, write a parenthesis. Okay? And then you name your cation, you name your anion, then you just combine them. Okay? So that's the idea in naming ionic compounds. There are some ionic compounds with fixed ions. Okay, for example, we have the bases here. For bases, the fixed ion here is the OH. Okay, the fixed ion here is OH. No, fixed yung OH. No, so it means that the names of bases will always end up with hydroxide. No, because the anion here is hydroxide. No? So that means all our bases will end up with hydroxide. So basically, your problem na lang is to name the cations accordingly. So this is sodium hydroxide, potassium hydroxide, calcium hydroxide, aluminum hydroxide. What's the name of this thing? This is iron 2 hydroxide, or we can also name this as ferrous hydroxide. Okay, as long as your formula ends with OH, that means it is a base. Okay, and what's the use of bases? We use bases as neutralizer for the acid. Okay, for example, if you drink Cremil S, if you take a look into the ingredients of the Cremil S, you can see there magnesium hydroxide, aluminum hydroxide. So the hydroxides there give you an idea that it contains OH minus. Okay. Okay, and that is used to neutralize acids. Okay, so for acids, the fixed ion here is the H plus. Okay, so that means the cation here will always be the hydrogen. Okay, so there are two ways in naming acids. Okay, so there is a name for non-oxy acid and there's a name for oxy acids. Okay, for non-oxy acids, medyo maraming gagawin. Okay, so what you have to do to name your non-oxy acids is to change the ide to ic, add the prefix hydro, then follow it with the word acid. Okay, so I'll give you an example. So what's the name of this ion? This is fluoride. If I combine that with hydronium ion, so what will be the formula? HF. What should I do in order to name this? Okay, so according to the rule, you change the ide to ic, you add the prefix hydro, and then you add the word acid at the end. Okay? Hydrofluoric acid. Okay, so you change the ide to ic, add the prefix hydro, then affix the word acid. Another example. Let's have another example here. We have this Br. The name of this ion is bromide because that is a monoatomic ion, so it should end with ide. If I add it
If I pair it with hydrogen, it becomes HBr. What's the name of this acid? The name will be, change the ide to ik, add the prefix hydro, and affix the word acid. Hydrobromic acid. Okay? So, ganun. If you see a hydro word here, that means that your anion ends with ide. Okay? So, ganun. That's the shortcut. How about this one? The last one. This one is hydroxide. If I pair it with hydrogen, it becomes water. Okay? What is the other name of water according to this rule? Okay, so this is hydroxide. Again, the ide will be converted to ik. Add the prefix hydro and affix the word acid. Hydroxyic acid. So that is one of the acceptable names of water. Hydroxyic acid or just simply hydroxic acid. Okay? So pwede mo na i-remove to. Okay? So you can just call it hydroxic acid. So you can see water has so many names, no? And yun na nga yung sinasabi ko earlier. In the US, there was a blunder in US. Let's take a look. Okay. So look at this first page here. It says ban dihydrogen monoxide. If you don't know the nomenclature, dihydrogen monoxide means water, H2O. Dalawang hydrogen, isang oxygen, H2O. Basically, that's water. And this was used by many people to prove that science literacy is very low in US. Okay? Because apparently many people were scared of the effects of the HMO or dihydrogen monoxide. Kasi ito yung sinabi nila, the HMO, it is known as hydroxyl acid. It contributes to the greenhouse effect, obviously, because there is water in the atmosphere. Can cause severe burns. Obviously, when you boil the water, it will really cause severe burns. It contributes to the erosion. Obviously, if it rains, the water will erode the soil, 'di ba? Okay. So that means if you really don't know the nomenclature, then you might be you might be fooled at the end of the day. Okay. Okay. Just for example, I saw this thing on Reddit, no, wherein that person listed all the chemicals that are found in apple, and then one anti-vaxxer said na he or she will not consume that. Okay. Okay, sabi niya, hindi ko kakainin yan. Hindi niya alam, nasa apple yon. Okay. So that means that if you don't know your nomenclature well, then you may end up being so ignorant that some people will find you funny. But however, that is a serious crisis actually in science. Okay, many people are very ignorant with the rules of science. Ayun. So that's why there are anti-vaxxers out there. No? They don't know how science works. So it is our goal to educate them. Okay. So let's not just make fun of them. No? You have to educate them then. Okay. So that's the rule for non-oxy acid. For oxy acid, the rule is simple lang. You just change the ate to ik, the ite to us, and just add the word acid. Okay? So very simple. So for example, we have here again the chlorates. This is the perchlorate, chlorate, chlorite, and hypochlorite. So again, as you can see, for perchlorate and chlorate, you just change the ate to ik. Okay? So this one is named perchloric acid. This is chloric acid. And for the ite suffix, this is chlorite and hypochlorite. Just change the ite to us. So chlorous acid and hypochlorous acid. Okay? So yun lang, very simple. And lastly, since we have 8 minutes na lang, I will just walk you through this. Okay. So for naming binary compound, this is actually for covalent molecules. Now, when you say binary compounds, we are talking about molecules that are covalent. Okay. Covalent molecules. So how do we name them? Okay. So first, you have to be able to write the formula first correctly. So what's the rule? The rule here is that the element that is farther to the left should be written first. Okay. For example, in water, why do we write water as H2O? Why not OH2? Because according to this rule, if your element is farther to the left, that means you have to write it first. And as you can see, hydrogen is the leftmost element. Okay, so that means H2O should you should write the H first before the oxygen talaga. Okay, so you have to write first the formula correctly. Again, the idea is that the element farther to the left should be written first, and usually oxygen is written last. Okay. Another example will be CO2. Why do we write CO2? Why not O2C? Because again, carbon is on the left and oxygen is written last. So this is the proper way of writing the formula, not this one. Okay? How about if they are on the same column? For example, sulfur and oxygen. Sulfur is below oxygen, huh? They are on the same group. Okay. However, sulfur is heavier than oxygen. So if that's the case, if they belong in the same group, the heavier element should be written first. Okay. So it's not O2S, rather it should be written as SO2. The heavier element should be written first. Okay. So why is it important that you indicate the correct proper correct na nga proper. Why is it important to write the correct way which kung sino yung element na mauuna? Because you will name the second element with the suffix ide. Okay? So kailangan you should really write the correct second element muna. Okay? Because this one will end with the ide. Okay? And then obviously you have to write the Greek prefixes. Okay? Except for the first element. Okay? Mono is never used for the first element. Okay? Medyo nag-hurry na ako kasi 5 minutes na lang. So anyway, so these are the names. This is actually wrong. Okay? Yeah. Okay, so this should be monoxide. Okay, so the name of this element, this molecule here is nitrogen monoxide. Okay, so nitrogen monoxide, again, oxygen comes last, so that means you have to affix the ide suffix. Okay, as you can see, all the second elements have the ide suffix. No, monoxide, fluoride, chloride, dioxide, monoxide, tetroxide, fluoride, decasulfide. Okay, so as it is the second element, no, you have to write the ide suffix. For the first element, you don't need to indicate the mono. Okay, so if you have one first element, you don't have to write mono nitrogen. No, you just write nitrogen. However, if dalawa na yan, then you can use the Greek prefixes, the di, tri, tetra. Okay. For the second element, you can use the mono. So that's why I crossed out these words now. So it should be mononitrogen, monoxide, okay, difluoride, so on and so forth, okay? So again, keep in mind that for the first element, never use mono. Okay, so yun lang naman yung rule. Never use mono, but the di, tri, tetra, they can be used. For the second element, it should always end with the suffix ide, okay? And you can use the mono here, okay? So monoxide, monoxide, okay? You can use the mono prefix. Another thing is that uh, if your prefix and the word of your element ends with a vowel, okay? Okay, for example, monoxide, okay? So you have to drop a letter, okay? So you have to drop the last vowel of your prefix. No? So instead of writing monooxide, you just write monoxide. Okay, so you have to drop the last vowel of your prefix, monoxide. How about tetraoxide? No? Tetra. So again, just like what we did earlier, if you encounter this problem, you have two vowels, one from the Greek prefix, one from the element. You have to remove the vowel of the prefix, no? So instead of writing tetraoxide, you write tetroxide. Okay? So yan, those are the rules. Again, we're actually done na. Minadali ko na kasi we are patapos na tayo. Okay, so anyway, so with 2 minutes remaining, so again, I just like to reiterate that there is a practice test in Canvas. Okay, so please try to work on these problems. This will be open until Saturday. As much as possible, try to maximize your attempts so that you can see the answers correctly. You can see the correct answers. Okay. And again, sobrang daming names, no? So that's why it's okay for me if you write your código with you. That's fine. Okay? Kasi sobrang daming rules, okay? And that's why I also provided this, no? Okay, that's why I also provided you with this ion list, okay? So you print this out, no? So because ang daming rules, no, sa nomenclature. Okay? Okay. Buti pa si Lord 10 yung rules. Ay, hindi lang, no? There are many rules in the Bible. Okay, yung Judaic. Ang daming sinabi, no? Ayan. Okay, so with that, no? So again, there's many things to be memorized. So feel free to write a código and then just download these files here, okay? So you still have plenty of time to remember this naman, okay? So yan. So again, thank you for attending our class. Tapos na yung ating oras. So I'll see you again next time, okay?